this. So it's actually thinking about this from the business's perspective. It's not thinking about as us, if this was an investment, us getting the money. It's thinking about the bank or the business is paying this out, right? So it becomes a negative balance for them. Or when an argument is, where's my remaining sentence? Oh, when the argument is entered as a negative number, that will also give you a negative answer, which makes sense. This is because the function follows the rule of inflow and outflow, where cash received will be a positive number and cash paid will be negative. So you can see it will probably be easier to download the file so you can read it on the same page and not having to go like in two different pages to read a full sentence out. I think it's just the way the preview is working. I did type it on a single page, I promise you. So, yeah, so that's what I wanted to show you. So since we were using different formatting, you will see the title is the same, but if you look under what type of links they are, it will show you one's a actual like YouTube link, the other one's a PDF file, and then the Excel spreadsheet. Alrighty, so that's why we were getting a negative answer. And it was this example, wasn't it? That we did? Yeah, the 99.30. This way. Yeah, so that was the example we had in the Excel file. Alrighty, so that was from last class. Any questions before we get started with the newer topic? Everybody okay? All right, so before we do get started into the comparison here, I did want to tell you that all of chapter 1 and chapter 2 homework is now open. You will see that I did go ahead and open up the homework on the biconditional statement. So it will show up at the bottom of the list of chapter 1 assignments. After section 1.8, you should see it just says homework. I think biconditional with truth tables or something like that is the title on it, which I guess I should be able to show you. Yeah, so you will see it's the last homework under 1.8 for the biconditional. And then I did include a practice. So that way, if you're done with the homework and you didn't want to mess with that grade anymore, you've got that 90% or whatever your grade is, so you can just leave it. And then these are the same problems that you saw in the homework, but you can do this as a practice. And as you can see, this is not for a grade. So when you're getting ready for the exam, you can just use that instead of going back into the homework and being worried about, oh, if I do this problem incorrectly, will it change my grade? So that way, even if you do it incorrectly in practice, it's not going to change your grade.
For the practice, it's not, you can't open chapter 2 until you're done with it. So do we have to score 90 for it to open?
With the practice, no.
Okay.
The practice does not count for a grade at all. So you will see to get into chapter 2, that first homework section, you actually need to get 90% on that biconditional homework. And it did it again. So 90% on the biconditional homework, because that one does count for a grade, but the practice, even if you do 0 on that, like don't even open it, it's not gonna do anything.
It's mine.
So, do you have 90% on the biconditional homework? Show me after class, just remember that. And somebody was supposed to remind me about something. Lori, was that you? I had asked you to remind me about notes. Do we want notes on our exam?
Yes.
Dumb question, right? Okay, we will do that. Alrighty. So, for the notes, not the 3 by, is it 3 by 4, the note card size, but the one next to it? Well, say that now size again.
5 by 5, the bigger one.
It shouldn't be a square, so it should be 2 different numbers. Because they're rectangular shape, right? What is it? It's the one your name tags are made of. Yeah, so that's the 3 by 4, isn't it? Whatever your name tag size is.
3 by 5.
3 by 5.
6.
Oh, but that would be too big. Yeah, let's do 3 by 5. 4 by 6, I think is the one I'm thinking of actually. So not this big, but the one in between. So 4 by 6 would be the largest you can go. So I guess not the name tag, but 1 size smaller than that. So yeah, whatever information you want to put on your note card, you can use that, but no other notes, right? So no textbook pages or anything else, just whatever you can fit on front and back of that note card. And the one thing I will tell you is do not throw those away after the exam, because you can reuse them on the final, because you remember your final is a comprehensive final exam. So don't discard them like, oh, I'm done with this exam now, so I will not need it. Keep it, because you'll need it. Alrighty, so that was our spiel on just all the changes I made in my open math and for the exam. So let's get back into section 2.2. So remember, we had kind of talked about how with simple interest, the interest is always calculated on the original principal, right? The original value you deposited, which I guess if it was a loan also, it would be the amount we borrowed, the original amount. But compound interest is always calculated on the original principal and, you know, whatever interest we have earned up till that point. So depending on what the compounding period is, whatever interest you have gathered up until that point, you get interest on the original principal and that interest, right? So we had seen an example where we talked about how it grows a little bit faster. So in this example here, we're talking about the amount of money earned from compounding in the previous example against the amount you would earn from simple interest. So the previous example is, again, this guy over here. So remember, the prompt was, it's a CD, which is offering us 6% APR. The deposit amount was $3,000. We're compounding this monthly, and the time was for 20 years, right? So kind of keeping those things constant, we're basically saying, okay, if this was if this was a simple interest, then the first year, of course, you would be right at $3,000, because that's kind of when we started, right? We deposited this money. And then the idea was, okay, so if you've gone through, and you can see they're not doing it year by year, they're saying, okay, 5 years, how much would we have earned? So again, you can do the math yourself, or you can just follow along what they have here. So this guy is saying, with the simple interest, we would be earning $15 a month, which would be 15 times 12, right? For a year, what does that come out to be? 15 times 12. $180, so over 5 years, and that would be 180 times 5, right? So you will see that amount stays the same. It's always going to be $15, no matter how many months you do it for, no matter how many years you do it for. So you will see the growth on the simple interest column is going from 3,000 to year 5 is 3,900. I'm going to skip down to year 20, and we haven't really even doubled that amount, right? Because we're at 6,600. Go down to year 35, and I guess we tripled the amount. No, did we? 3,000 to 9,000, but no, we did not even triple by the time we got to 3,500, because you're at 9,300. But then look at the compound interest side. So remember, this was where we take the 6% divided by 12, since we are compounding the interest monthly. And as you can see by that calculation, we come out to be an interest rate of 0.5% each month, right? So you're not actually earning a constant $15 monthly interest. You're actually earning a percentage. So that's going to be 0.5%. So you will see, again, year 1 is the same, or year 0, I guess, is the same. We have both 3,000 and 3,000. But then look at year 5. You went to 4,046 and $55. So that's over $100 difference, right? Between simple interest and compound interest. And then you can see, what did I do next? Year 15. So 5,700 on the simple interest side, which is now 7,362.28 cents over there. So again, what are we looking at? 1,500, more than $1,500 difference between the simple interest and the compound interest. And then if you just go down to the very last row, 35 years, you will see we were at 9,300 in simple interest, but look at compound interest. That is more than double of what the simple interest account earned, right? Because you're now at 24,370.65. And look at the graph over here. The blue line is your simple interest because simple interest grows at a constant rate. But look at the pink line, I guess, which is the compound interest, and you will see that is what we call as an exponential growth, right? Because it took that turn. So you can see kinda for that first 5 years, they were not too far from each other, right? On the graph, if you look at them, they're kind of seeming to go almost on top of each other. I'm sure if we were to zoom in, it would look a little bit difference between the two, but you can kind of see we were at 3,900 and then we went up to $4,046. So not like a huge difference, but then as more time goes by, look how further apart those two lines on the graph get, right? And that's what's happening with compound interest. And remember from the formula of compound interest, we have just looking at the two formulas between simple and compound. Just change your bar reading, it should be working. Okay. Let's bring in the other guy. All right, so remember for simple interest, our formula is A equals P times 1 plus RT, right? Because there's no compounding period. But then for the compound interest, we have A equals P times 1 plus, and then this is where it changes, right? Because we have those compounding periods. So R divided by N, and then you raise it to the exponent of N times T. So you can see where that exponential growth is happening, right? Because our time is an exponent here because we're doing N times T. So that tells us how many compounding periods we are going to have. And that's actually where the difference starts happening, right? That growth of the exponential function starts happening on the compound interest formula. So, you know, as an investment, we would prefer doing compound interest, right? Because we can see we're earning better interest on that. Now, if this was a loan, we probably would not want to pay a compound interest loan, right? Because obviously then that means we're paying a lot more in interest. So, yeah, those are some of the things, you know, we got to be mindful of when we're kind of looking at these monetary financial decisions. Alrighty, so we have, in this example, looked at if we knew how much money we were going to deposit, what our future balance would look like. But what if we were working backwards? What if we needed to find out what our principal or present value would be? So, and we had kind of hinted at this earlier. So we had talked about, you know, what if we wanted to like save money for a car or a kid's education or something like that. So we know that, you know, we would need this much amount of money. And I think we had settled on $25,000, if I remember, somewhere in there, right? So if we need that $25,000 in, you know, 3 years, 4 years time, then we can say, okay, so I need to calculate how much money am I depositing today so that in that time frame I can have, you know, my payment for the car or whatever we're looking for. So of course that means we're solving for P. They're saying you can basically rewrite the formula by using a little algebra, you know, divide both sides of the formula by the quantity that was multiplied by P. And then of course, we also have a built-in spreadsheet function that we can use. Are they showing us the rewritten formula? Yes, they are. Okay. So let me show you how the math on that would work out. If we are doing this with compound interest formula. So again, remember our compound interest formula. I just erased him, but here it is. So P is being multiplied by this whole parentheses thing, right? Parentheses raised to the power of NT. So if we wanted to get P by itself, we would divide both sides of our equation by 1 plus R over N raised to the power of NT. Right, so as you can see, then that means we would be able to cancel out those parentheses on the right-hand side, and we can say, okay, rewriting the formula will end up, and I'm just going to put P on the left, will basically give us, as you can see, we have A on the top, and then it is being divided by 1 plus R over N, and that parentheses is raised to the power of NT. That should look like an N, not an R. So that would be your rewritten compound interest formula for finding the principal or the present value. And then, of course, you can see the built-in function is called PV, present value, right? And a lot of those arguments look the same, right? The rate per period, the number of periods, that money is going to, grow in a way, payment amount and future value. So in this case, you're entering how much money you want at the end of your time, right? Now, just to remind you guys about the payment amount would be if you were going to make regular payments into your account, right? So if you started out with, I'll just use $3,000 from our previous example, but then you're like, you know what, every month I can add $200 to keep that account growing. But then that means if you're taking this investment account for, what did I say, 3 or 4 years, then that means you have to make that $200 every month, or whatever your compounding period might be, which I guess could be anything. Then you have to be able to make that payment regularly. And that may not be an option for everyone. So again, remember, for our purposes, we're going to be using that argument of payment amount as 0 because we're not going to be making those regular payments. Because, when I think about this in practical, yes, there might be a month where maybe we can make that $200 payment, but then it could be we go a couple months where we're not able to do that, right? So it's not always something that we can do. So that's kind of my argument for why we would leave the payment amount as 0, because we may not be able to do this regularly. All right, so let's take a look at an account here. I'm going to try and leave this formula up for now so we can follow along with that guy. So let's look at this 226 example. You know that you will need $40,000 for your child's education in 18 years. The amount seems small to me, but maybe it is doable. I'm not sure. So we're basically saying we need $40,000 in 18 years. The account will earn 4% APR compounded quarterly. So let's see, we need $40,000 in 18 years time. The APR is 4% and it's compounded quarterly. And they want to know how much should we deposit now so that we can reach that goal. So 40,000 is what? In terms of all these values that are mentioned in that block above.
Future value.
Very nice. So 40,000 is the future value or the A amount. 18 years will be
Time.
T. Very nice. Very good. That's the T value. 4%.
R. Great.
Very good. 4% is the R. And that leaves us with compounded quarterly. What is compounded quarterly? Sorry? I'm hearing whisperings, but I'm not hearing like an answer. Yeah, 4, very good. And that will be the variable n, right? Because when we're talking about compounding, we're talking about the n value. And yeah, as Corey said, since it's quarterly, the n value is going to be 4. So you can see we have all the information we need. So I'm going to show you using the formula first, and then we'll show you with the spreadsheet formula, built-in formula. Alrighty, let me get into our spreadsheet function. And again, guys, you have the option of using Excel or Google Sheets, whatever, I guess, your computers, your machines have. For Google Sheets. Yes, a blank spreadsheet would be nice. Thank you. Access into my own. But technology was supposed to make life easy for us. Come on, buddy, I'm just looking for Google Sheets here, people, nothing big. I think I just need to bookmark on Google Sheets, knowing that we will be using. All right, there we go, finally, thank you. I just didn't want you guys to see the mess I was making on my laptop, so that's why you didn't see the 5,000 steps I just jumped through to get it to Google Sheets. Alrighty, so let's see, we have a value of 40,000, and remember how we had talked about formatting? So I'm actually going to turn this into dollar amount, right? So $40,000. Our rate of interest, is 4%, which the percent will change it into 400, and then make sure we bring it back to 4. Let's see, our compounding was quarterly. So we know that's 4, and then our time, of course, they told us was 18 years. And T usually, as I had mentioned previously, also is supposed to be in here. Alrighty, so I think we have everything in there. So now let's talk about calculating our function value here. So again, I'm just typing in the formula that I have written here on the right-hand side. So that's A divided by 1 plus R divided by N. And then, of course, the parentheses is raised to the power of N times T. Just so you can kind of see it a little bit more spread out. But I would definitely write this guy down also, just so you know what it looks like on its own. Okay, so how do we calculate that? So we're calculating P, so of course, start out by using the equal to sign. And then we're doing A, which is 40,000, and then we're gonna divide A, because A is the only value on the top. So everything on the bottom needs to go in parentheses, because we need to tell the program that 1 plus R divided by N and raised to the power of NT is one single quantity. So we need to be able to do it in parentheses. So you'll see I went ahead and did my blank parentheses first, and now I can type in my value. So we have 1 plus R divided by N, and you can see I'm again just clicking on the cells, right? And since 1 plus R divided by N also needs to be one single quantity, since the exponent is raised to, that grouping, you will see I'm actually now introducing a second set of parentheses just to close 1 plus R divided by N, but between the two closing parentheses is where I'm going to put my exponent. So that's where my exponent, and then in parentheses again, guys, because again, N times T is one single quantity. That will be N multiplied by T, and then I'm closing that parentheses also. So you can basically see in our grouping here, let me see if this guy can. Okay, so you will see that 1 plus R over N, I'm grouping together by using parentheses. And then N times T is the second grouping I'm using. And then, of course, all of that to show Excel that that's a denominator, we're grouping it again. So there's technically 3 sets of parentheses that's happening here. The other way you can do this, and I'm just going to hit enter so that you can see what that answer comes out to be. And then if you wanted to see the formula, you should be able to see it up here on the, and I know it's kind of tiny. The other way you can do this is a basic regular scientific calculator. So let's see, we had $40,000 divided by, and again, parentheses, because we are grouping this 1 plus R, which was our interest rate. Remember, 4% as a decimal will become 0.04. And then that number was divided by N. Remember, your N was also 4. Close that parentheses, and then we're not raising it to the second power, right? It's N times T, so it's going to be A to the power of B. That just gives us the exponent option. And then I'm going to put this in parentheses again, was what, N times T, which was 18. So you can use, and this would pretty much be the same step, which I guess I forgot to bring our handheld calculators today. I can grab those here in a minute, but you will see this guy is also giving us the value of, let me clear this out, $19,539.84 if we round it to the nearest cent. And is that what we had here? 19,539.84. And you can see since we had pre-formatted that $40,000 as a dollar amount, our interest came out rounded, right? We didn't have to worry about rounding it. Now, let's say if I remove this formatting here and, where's my format? Maybe I'll change it to plain text. You will see how your principal amount changed into the multiple decimals, right? Instead of 2 decimal places. But if you go back and put this as a dollar amount, you can see this guy fixes automatically. So again, trust me, Google and Microsoft are not paying me for this. I just love working with spreadsheets. Questions on using the formula to come up with present value. The P equals, A divided by all the fun stuff. Okay, so far? Raven on Zoom, are you okay with that example? Yeah, all right, so now let's see the built-in PV function. So let's do that. Same thing, start with equal to, and then we'll do PV for present value. And then here, you will see they're giving us the rate, number of periods, payment amount, future value. But before we can do that, let's come back. Oh, where's my textbook? So remember how here you actually have to do a little bit of math, right? Before we can put this into our function. So the rate technically is the R divided by N value. The number of periods is the N times T. And then A, I guess, is the only one we're not modifying. So we actually need to calculate those before we can put them in the formula, or you need to incorporate R divided by N and N times T. So I'll show you both ways. So if you wanted to do the rate is R divided by N. So you either type R divided by N values in there. So that's the rate argument, comma, number of periods is N times T. So that becomes our second argument, N times T. Remember, we said we are not making any payment, so that number is going to be 0. So put that as a 0, and then comma, the last one is how much money do we want in the future, which was, of course, our little $40,000 there, right? And then you can close your parentheses. So this way you don't have to do the calculation separately. You're letting the calculation happen within the function itself. And remember, again, we had talked about how this is giving us negative values. So that's what's happening. The other part would be you do the math separately. So you do the R divided by N and you do the N times T. So it's still going to give you the same thing. R divided by N was this guy divided by this guy. And no, this is not a division, so I don't need to autofill this, right? So this would be N times T. And then you can come back and do, the PV function. And we would say, okay, the rate was the R divided by N. The number of periods was the N times T. Our payment amount is still 0. And then our future value is 40. So that would be the other way to do it, right? Do your calculation separately and then use those to put it into your function, but it's not going to make a difference in your calculation, as you can see with both of those formulas next to each other. So just whatever you think would be easy for you to keep track of. And of course, if you prefer the formula itself, you can do that also. But this may be something to think about, and let me think on that. Maybe we could let you guys use spreadsheets on the exam, right? So open up a spreadsheet and use that as your calculator instead of handheld or Desmos. Because, again, we are kind of encouraging you. And when we get to chapter 3 and chapter 4, when we talk about statistics and probability, yeah, if you don't even like spreadsheets, we're still going to be using spreadsheets in that. So it may not be a bad idea to maybe get a practice run with chapter 2. So I think that might be something to think about. I think that might make your life and mine easier. So questions on using either of the methods on finding the present value. when you know how much money you want in the future. Good? Alrighty, let's move on then if you guys don't have any questions. And of course, you should be able to compare that answer with the example in here. So we have talked about how a compounding period, and I know your textbook had listed those, can be, where are you? There you go. So compounding can be done, of course, just once a year, which still would grow faster than simple interest. Even if you were compounding once a year, the first year would be the same for both, but after that, you would see compound interest have more money than simple interest. So compounding can be done once a year, quarterly, monthly, weekly, daily. And I think I had entered this last time. It can also be done semi-annually, which would be every 6 months. So in this case, your N would be 2 because we're calculating interest twice a year. So it's annually, semi-annually, quarterly, monthly, weekly, daily. I think those would be the most common compounding periods you would see, okay? So when we are talking about continuous compounding, would mean it would work a little bit faster than daily, right? Because continuous, we're saying it's kind of in a loop, right? Think about it even faster than every second that it is calculating your interest rate. So continuous compounding, and you can see they're saying in many bank accounts, your interest is compounded continuously at each moment in time, basically. So the number of times per year, in this case, your N value would actually be infinite. Because, again, we're just saying it's going continuously. So as N approaches infinity, your compound interest formula will actually change to this guy over here that we're seeing. So I call it the PERT formula, because it makes it easy to remember the order of the variables, right? So you have A equals, which is still your future value. P is still the present value, but this is actually the natural number E. This is not a variable. So it's P multiplied by E, and then E alone is raised to the power of R times T. So you can basically think, okay, T is being multiplied with the factor of E to the power of RT. So in this case, you will see, since this is continuous compounding, we do not have the N value, right? You have the principal, the future value. You have the rate of interest and how long we'll keep the money in the account, right? We do not have a compounding period like N equals whatever, because in this case, that E to the power of RT is taking into account that this is continuous compounding. It's just basically nonstop doing the compounding. So you will need to know where to find that natural number E on your calculators. In Desmos, there is no natural number. Really? There you are. So you have to go under the function option, and you will see, you will find that natural number E. Now in handheld calculators, if you can find the LN key, it's usually right on top of the LN key. So if you, because I think the log and natural log are the dominant keys. And on top of that, you should have, so yeah, there's your LN key. So you'll see that E is the second shift option. So yeah, find the LN key on your calculator, and you will have to use the second or the shift key to get to the E in your handheld calculators. But like I said, Desmos has it under function, and then does Excel have natural number E? There you go. So it is the EXP for the natural number E under spreadsheet. So EXP, and then when you do the parentheses, you'll actually be putting what the exponent will be. So we'll play around with that, but it is in Excel, Google also. Okay, so the PERT formula is what we use for continuous compounding, and they did actually kind of break that down for us here. In the textbook, you use the equal to exp function for the exponential natural number e. All right, so let's look at this guy over here. You deposit $4,000 in an account that earns 2.75 APR, which is compounded continuously. They want to know how much money we will have after 7 years, how much interest did we earn, and what percentage of the balance is interest. So let's see, we have 4,000. Can I copy you? Yes. Okay, good. All right, let's come in here. And I'm actually gonna do this on a. Okay, so we should be able to see that. So remember, we're talking about depositing $4,000, but that makes it the p-value, right? So 4,000, and we're again going to format this as a dollar amount. We are earning an interest rate, so that's the R value of 2.75. Let's see what happens when we make that into a percent. It still makes it 275. So let's put a decimal in there, 2.75. They want to know after 7 years what the balance will be, or how much money, I guess, we want. And I think that's it. How much interest did you earn? What percentage of the final balance is the interest? So remember, the formula is A equals P times E raised to the power of R times T. And again, I'm kind of putting in parentheses, so we'll remember that R times T needs to be grouped together, and that acts as the exponent on E. So if we were typing this by hand, then we would of course say, okay, we're taking equal to 4,000 as our principal, multiplied by our natural number E. So remember, that was the exp function, so just type the exp. And I'm actually using the tab key on my keyboard to accept the function. So when you type the numbers, the letters in, and you know this is the function I want, you can use the tab key, and it gives you the capital exp with the parentheses. Now remember, the exponent here is supposed to be R times T. So you're going to do R times T and then close the parentheses. So just take a look at that, guys. So we did 4,000 times the exp function for the natural number E, then that is raised to the power of R times T. Now you will notice we didn't have to use the caret symbol, because the exp function is built in, that you're typing in the exponent in the parentheses. So you don't specifically have to do the caret symbol here. Alrighty, and then you can see this guy is giving us, I was hoping for more money. $4,849.11. So let's do that with the calculator just to make sure we're replicating the math, right? So 4,000 is our deposit. We're multiplying it with the natural number E. Now with this guy, we will need to do the exponent. So we will actually come back, or no, actually they're giving us the exponent option here. So you can click on that little guy. There we go, and we've got that exponent. And again, in parentheses, the R was 2.75. So what is that in decimal? 2.75 in decimal.
0.025.
Very nice, 0.0275. Multiplied by, what were we doing, 7 years? And again, you can see this guy is giving us 4,849. And then since that's 106, the 6 makes the 0 go up, right? So 11 cents, 48, 49, 11. And you can see that's what we had from this guy here. I actually don't think, is there a built-in function for continuous compounding? I'm not familiar that there is, and looks like a textbook's not talking about that either. So yeah, this one wouldn't have, like how we had the FV, PV functions, we wouldn't have that option with the continuous compounding. So we would need to go with the PERT formula to come up with that. All right, so let's answer these questions. So we know after 7 years, we will have $4,849.11. How much interest did we earn? How do we calculate the interest? Because this is the total amount, right? The future value is the total amount. So how do we find out just how much interest did we earn over those 7 years?
Correct. Your, the first value from the present value.
Your deposit, right? How much did you start out with? What was your initial balance? So yeah, we're gonna subtract the principal from our future value. Interest is A minus P. Or FV minus PV, whatever you wanna call it. So interest is A minus P, which would be, A is the number we just calculated minus the original principal. So of course you can see $849.11 becomes our interest. Now, the last part is asking us what percentage of the final balance is interest, and we had actually done, you know, when we had talked about problem solving, wasn't it in section 1.5? Or was it the percentage section? One of those sections we had talked about, how do you set up your formula once you see how the question is worded, right? Or how the relationship between values is given. So how would you calculate this? The percentage of the final balance is interest. Remember those keywords we have talked about? So what does of and is represent? For which one?
Of
And you said division, for which one? Divide, I don't think I heard that. Divide what? To divide the interest by the future value. Okay. So yes, in that case, I can see why you were talking about division. So I was just asking, what do the terms of and is represent? So we said of was multiplication. What is representing?
addition.
Simple, is equal to, right? So is will
Yeah.
always be for equal to. So if you were just generically setting this up, we're saying, okay, some percentage multiplied by the final balance is equal to interest, right? That's basically what that question is setting up for us. So as Lauren mentioned, to calculate the percentage, and I'm just calling X for the percentage, you would then say, yes, interest divided by final balance, because they're kind of telling you there, right? Find the interest based on the final balance. So that would be our 849.11 divided by the 4849.11. So as a percentage, what does this guy come out to? Very good, yeah. I'm just gonna change that to a percent. So just depending on how many ever decimal places they want to go to. So let's see what your textbook says about this guy. Alrighty, so we have yeah, you can see we got the same number, $4,849.11. And then I guess they're breaking it up into two parts. So how do we calculate the interest and the percentage of the interest? And you can see that right over here. So A minus P gives you the interest, 849.11, which is again the same thing we got. And then to come up with the percentage, we can see basically what Lauren told us to do. Take the interest divided by the future value. And looks like they're rounding it to 1 decimal places. But again, we had the 1751, right? Once we did our conversion from decimal to percent, so it becomes 17.5. So a growth of 17.5 is actually not bad, right? Over a 7-year period. But when you just kind of look at it in dollar amounts, it's like, oh, so we just went from 40 4,000 to like 850-esque more, so not as much as we would have expected, but then when you convert it to percentage, we're like, actually, 17.5 is not a bad amount of growth, because we did start with 2.75 interest rate, right? So that was not a high interest rate, better than 1%, which we had for the very longest time there for how many years? So 2.75 kind of makes sense that we wouldn't see like a huge dollar amount, right, for the interest.
What would the end value be if you ran it for another year?
So instead of 7, we did 8 years?
Yeah.
Yeah, so again, and this is why I remember talked about using cell reference. Let's change that for 8 years. And you see how all the math changed? So you've got now 4984.31, 984.31 becomes the interest, and now you'll see our percentage went up to 1975. And this is again the reason why I like doing cell references, because then you get to play around with numbers. So yeah, look at that. You get what, just shy of 5,000 in that case. And this comes back to exponential growth, right? You would not see this kind of growth if this was a simple interest. So look at that. You went from 849 to 98.
How many years would you have to have it running for to have 100% interest?
Oh, that's a good question. I don't know. We'd have to play around with those numbers. I'm just randomly going to throw that in there. And you can see we did double quite at 20 years, right? How about just 30? So somewhere between 20 to 30 years, right? And then you just play around with the finer numbers. I don't know what 25 would give us. Just shy.
But for 100% interest. So every single time it's running, then you're,
Well, 100% interest would basically mean you double the principal you started with.
yeah,
So it looks like you would have to be close to 26 years to get to 8,000.
but that's only a 51% interest.
So, well, because it's taking the difference between just the interest amount too, but this is technically 100% earning because you started out with 4,000 and you're now at more than 8,000, right? So technically you are at 100% interest. Do you see what I'm saying?
Yeah.
But you're saying that percentage to be 100?
Yeah.
Oh, I don't know. Apparently, we will not be alive by the time that guy becomes 100%. What? I'm just going to 100. So I'm tired. Seriously, buddy, come on. I am dead at this point. Even my other generations after me are not around. Oh my God, seriously? No, no. This is, I think this is broken. 250? Oh. I'm giving up. I'm
It's going
sorry.
up by smaller amounts. every
Yeah,
time.
so the growth obviously is not happening, which again, none of us would be alive to even really worry about how much money we have in our account, right? But I mean, it can be done, and you can see, just play around with that T value and see how long it takes you to get there. Question on just solving that problem. We're okay? Good? Alrighty, let's get into this last part on section 2.2. So we're actually talking about effective rate, and we had kind of just hinted at this at the beginning of this chapter, or maybe this section, that, you know, when we're talking about doing comparisons, that's where the effective rate would come into play. So we're basically saying you're shopping around for different investments. You might need to compare different rates, basically that have different compounding periods. So if the rate and period are different, it's hard to know which account would basically give us a better result, right? Better earnings, especially since we are talking about investments. So there is again a spreadsheet formula called effect that we can use for this. And we're actually going to be using the effective formula, and you will see we don't really have a non-spreadsheet formula, right? So we're just using the spreadsheet to calculate this guy. So there's not an A equals P, whatever formula for this guy. I mean, there is one, we're just not using it. All right, so we're gonna use that. And basically the results that you get from using the effective rate is actually what we call as the annual percentage yield. So we're basically saying, you know, APR is the rate, right? So it can be 4% compounded quarterly. It can be, what did we see, 2.75% compounded, I don't know, maybe monthly or, something like that. So you can see one is higher, one is lower, but then the compounding periods are different. So at the end of the year, how much interest did we really earn on our investment over here? And that's what the APY tells you. So again, if you were to go online and say, I'm interested in getting a CD deposit. And there's this really good website that helps you do that. I don't know if you guys are familiar with bankrate.com. So you can see, this is giving you, if you wanted to do like a higher yielding savings account, you wanted to do CD rates, or they also sometimes have money market accounts in there. But let's say we were going with CDs. Well, apparently the best one we are getting after the Fed dropped the interest rate is going to be 4.5%. But you will see they are, if you guys can see that little tiny writing, but right over here, it's telling you that's an APY value, right? They're not giving you the APR. A lot of times, and again, I'm not a banker, so this is just based on my experience, but as I understand it, CDs normally do compounded daily because they calculate an interest rate on a daily basis. But again, once you get into like the detail, like, okay, I'm going to purchase the CD, then they'll kind of break down the math for you. But most of the time it is, and I think this is just information on the bank, but not so much on the CD itself. So yeah. So that's why we need to know what an APY means. What does it come out to be? So for our effective rate formula, we need to know what the standard rate is, which is going to be that APR, right? And then of course we need to know what kind of compounding are we looking at? Is it monthly, quarterly, daily, those kind of things. So then we would do the end value, and you can see those are the only two arguments that goes into this formula. So let's look at this guy here. So we're comparing an account that is paying 5.25% APR, but compounded monthly, and the other one is paying 5% compounded daily. Now, if you were just looking at the APR value, we would say, hey, 525 looks better. You're going to get 0.25% more interest, but then you are only getting that interest calculated once a month. Whereas with the 5%, you're getting that interest every day, right? So that's why that compounding period and the rate both have to go into consideration when we're trying to figure out what the effective rate is.
And this formula is to find the APY.
Just to find the APY, yeah. So let's take a look at this fellow here. And I'm just gonna put him in the new spreadsheet. There we go. So we can see this better. So again, we are using the effect. And again, you can see I typed EFF and then I'm using the tab key on my laptop to get the whole thing in. And you can also use your pointer or your mouse to get it in there. Okay, so we know our nominal rate is 5.25. I guess I actually didn't set that up, did I? Let me do that first. All right, so our APR or the rate is the 5.25%. And again, formatting is going to make it 525. So make sure we come back and put our decimal in there. And then our compounding period for this specific rate was monthly, right? 12%. Then for the other account, our APR is 5%. And again, we'll need to get rid of the zeros. So 5%, and then this guy was compounded daily. Now remember, for daily, we said for our calculation purposes, we're using 365. All right, so let's find the effective rate for both, it's EFF, there we go. So you do the nominal rate first, so we click on the rate box first, and then the compounding period, right? How many times are we compounding this? So you can see this guy is coming out to be 0.05. I mean, we're still in the neighborhood of 5%. It's not going to change dramatically, but change that to a percentage. You can see this is approximately 5.38%, right? So you are earning a little bit more than 0.25, because this is going up to 0.38. So because of that compounding period, right? 12 months. Let's see what happens with the 5% at daily compounding. So again, effective rate formula. We're gonna click on the interest and then the compounding period. Close that. And then convert that to a percentage. So even though that guy is being compounded daily, you will see, since we did start out at a 0.25% lower, and again, if you guys just wanted to see how we got those formulas in there. The daily one is still not matching up to the monthly, right? Because he was at 525 and then that monthly is just making it go up a little higher. So now we can choose and we can say, okay, I think I want to invest in the 5.38% APY account because that's going to give me slightly better. And this is kind of what we're doing over here, right? When we're looking at this website to see which CD is giving us a good interest rate. So you can see, would you go with a 4.5% or would you go with a 4% or a 3.25? Now, of course, in practicality, we would make sure the bank is legit, right? We are actually not gonna, like, money's not gonna disappear, because that's actually happened with a lot of these fintech companies. You know, those apps you see advertisements for, like, you know, where this bank that doesn't really exist, but except in the virtual online world. And people have actually lost money because they were not legit banks and people didn't realize that. So gotta be very, very careful. And that's another reason why I use this website, because financial advisors use this website. So I'm kind of thinking somebody somewhere knows something, right? But we should always do our own research before trusting people. Now, going back, you can also see we had the high yield savings account. So let's just see what that APY is looking at right now. And you can see these ones. Oh, apparently Genius Bank is giving us 5.05 APY. Lending Club is at 530. So a little bit higher than what we saw with the CDs, right? And the way I understand about these high yield savings accounts is basically they are not physical banks, but they are associated with physical banks. So the one bank that I am familiar with, it may not even show up on this list.
Chase is there.
Well, but I want to know what their online bank is. So like there's this bank out of Connecticut or one of those New England states. There's a bank called Webster Bank. Registered with FDIC and all of those good stuffs, but they have a online high yield bank savings account through what they call as a Brio Direct Bank. So it's actually their own bank, but they can use this as a subsidiary and say this is an online account, so we can actually give you a higher percentage. So like if you walked into one of those Bank of Colorado or something, they may give you like maybe a 3.5% APY, but if they had this virtual environment bank, then they could say, because we don't have overhead expenses, we don't have staff we need to pay for, lease for the property, and all those other expenses, instead of 4.5 that the physical bank is offering, we can give you like maybe 4.15%, right? So they can kind of take some of those expenses and move it towards, because they're still getting your money sitting in their bank and they're able to do that for other loan giving or whatever, but you get to enjoy a little bit higher bank. So sometimes be careful about like what you're seeing here, because they could be those virtual banks, but make sure they are actually associated with a known national or regional bank before, we put our hard-earned money. Like you will see, so this guy here, Marcus, you can see it's basically saying it's by Goldman Sachs, right? So the Goldman Sachs is the big bad banking company, and then Marcus would be there, maybe that online subsidiary or whatever. Hey, we're going to give you 4.25%. So that's kind of why just looking at the APR and the compounding period is not enough, because just looking at it, we couldn't say, like, I was honestly thinking daily might be better because you're earning interest more often. But then you can see once we did the math, he is still shy it didn't even make it to the 5.25 that the other account was giving, right? It's just at 5.13, so just not enough. When you have the option of going higher, right? Why would you go with the lower interest rate? And again, you can compare that here. And you can see 5.38, 5.13, the two percentages we came up with. Okay, let's look at 2210. This guy is saying find the effective rates to compare an account that earns 6% quarterly with the account 5.975 compounded daily. So those APRs are pretty close to each other. So before we do the math, just give me a guess of which one do you think should be higher between the two? The 6% or the 5.975?
5.975.
Okay. Anybody wanna go with the other guy? No? Nobody wants 6% interest? Okay. Yes, I will go with 6% interest. All right, there we go. So we have, let's see again, APR and then the compounding period. So the first one was 6%. And again, we'll need to get rid of the zeros. The other one was so 5.975. This guy, 6% was compounded quarterly, so that's 4 times a year. And the other one was daily, so he's 365 times a year. All right, so now let's talk about what its effective rate will be. So again, effective nominal rate for the first one was 6% at compounded quarterly. So you can see this one is going up to 6.13. And then I'm just gonna copy that guy over and then change it to a percent. Oh, so 6.14. And then the other guy is going to be, and Samuel, and I guess most of you went with the daily compounding with 5. If you will. Let me see if I can get this guy too. There we go. I don't think it's gonna make a difference in the calculation, but I'd like us to see that it was at 9.7. Not like life-changing difference, but it is higher. Even by 0.02, it is still higher than the 6% compounded quarterly. So yeah, you can see when the interest rates are close enough to each other, the more compounding period can kind of give you that slighter edge, right? You can go a little bit higher, but maybe other factors come into play for how long are they going to keep your money? Is it going to be for like several years, or is it only going to be for like maybe a year or two, and you're going to get that interest earned quicker? And then kind of depends on us. How long are we able to keep the money in this account? But yeah, so you can see technically the daily at 5.975% would give you a higher yield. Questions on this one here, guys? Raven, did you have any questions on any of these? We're doing okay so far? And then, yeah, you can see 6.14 and 6.16 with this guy also. Sure, why not? Let's do number 11. Or actually, you do number 11, and then we'll talk about the answers. So number 11 is talking about $10,000 deposit in an account earning 4% APR compounded weekly. How much will you have in the account in 25 years? And then the other questions are, how much interest will you earn? What percent of the balance is the interest? And the last question is actually asking us what percent of the balance is the principal? So Now, since this is telling you compounded weekly, right, this is not a continuous compounding problem, so just make sure you know which formula you are using. Alicia, you look like you're kind of,
No, I'm just trying to read.
okay, do you want me to make it bigger?
No, it's okay.
Okay. So let me see. Let's just start out with what our balance will come out to be, right? So that will be question A. Let's start out with just A in 25 years. What would that balance on our account look like? So again, you can use a spreadsheet, you can use handheld calculator. If you do not have a device on you, then I guess for now, use your phone. Give your neighbor device? Sure, why not? And again, just to let you know, the Learning Commons will rent out laptops if you need to rent one out. Well, then I guess I do have a calculator here as well, if anybody needed to borrow one. I'm gonna see if I can copy this over to our spreadsheet while you guys are coming up with these. Have the answer for part A, what would we have after 25 years? What the formula typed in there, the P times 1 plus R over N to the power of NT, or of course, if you are using a spreadsheet, then you can also use the FV function to come up with that. What is our P value here, guys? 10,000, because they're telling us we're making a deposit. So that's how we know we have a P and not an A value. Now we'll format that into dollar. Our rate, 4%. And again, format that into a percentage and make sure we get rid of the extra zeros. 4%. What's the N value when they're talking about compounded weekly? How many weeks in a year? Yeah, very nice, 52. Well, for counting purposes, we think about it as 52. Because, it's the same concept, you have that quarter day, and that's why we have the leap year, so we're not thinking about leap years. All right, and of course, time, again, remember, is always in years. All right, so now that you have your PRN T values, what is the balance in the account after 25 years? Raven on Zoom, do you have an answer? I would love to give you all the time in the world. But I guess I'm just gonna have to let you do that on homework. So I'm starting out with the P times 1 plus R over N raised to the power of NT formula. So our principal is 10,000 times, again, just one times, parentheses, 1 plus R divided by N. And then remember caret symbol for the exponent, and then parentheses again, we do N times T. Was anybody close to this number? Yeah, Dominic? $27,172.37. That's what you got? That's not a bad growth, right? I mean, you're more than double, more than two and a half times. Yes, technically 2.7 times. All right, let's see with the built-in function if any of you wanted to use that. But remember, this is again where you need to calculate R divided by N, and you need to calculate N times T, or you can put it in the function. So I will let you decide how you want to do that. So you can do R divided by N, and then we can do N times T. So in our function you can kind of see that at the top where the edit box is. Right here is where it's going. So our rate was R divided by N, comma. Our number of periods were N times T, comma. We're not making any regular payments, so that guy is 0. And then present value, of course, we're starting out with $10,000. And as we talked about earlier at the beginning of class, this will always give you a negative answer because it's thinking that the bank is paying this out, right? So it's a negative number, but you can see, of course, it matches with our formula-based answer. Questions on this, guys? And again, do not bother about rounding that R divided by N over here, because if you round the answer here, this guy will come out to be incorrect. So whatever 10,000 decimals it has, leave it as it is. We do not round at the intermediary steps. We always round when you get to the final answer. Okay, so this was part A. Okay, so for part B, they want to know how much interest will you earn? So how much interest have we earned with this earning deposit here? Can you give me a dollar amount? Very good. So you're gonna take the future value and subtract the principal from that. And it should be whatever minus 10,000, right? So 17,000, like you said, on 172.37 cents. Part C and D is now getting into the percentage side of it. So let's talk about that. Part C is talking about what percent of the balance is interest. So what would you do to calculate this percentage? What percent of the balance is the interest? We already did this math before. What is it, people?
$63.19.
All right, you want to tell me what math you did for that?
The interest divided by the balance times 1.
Very good, yeah. Then multiply that by 100 to convert this guy into a percentage, or in spreadsheet, we're just formatting it. I guess I should mention that this guy is the interest here, so we know what we're looking at. Okay, part D is asking what percentage of the balance is the principal? $10,000 and what else?
That's the principle, that's what you started with.
Okay. So what percentage of the balance, which is the A value, is going to be the principal, right? Because they're both asking you to do this based on the balance, it's actually gonna be the 10,000 out of the 27,000. Dominic, did you have that? Or were you still working on that?
I got 36.8.
Yeah. And you know, the rounding can be based on whatever my open math will tell you. They may have you do 2 decimal places or 1 decimal place, but I think the crucial thing is, are we able to set up the problem, right? Are we able to make sure we're using the right numbers to do the math? So question on any of this 4 parts of the problem? Yes.
Can you remind me for the A equals P parentheses, what that part, where do the 2 parentheses go? Like you said, there's.
So, what are you using to calculate will depend on that. Are you using Desmos or Excel?
Desmos.
Okay, so in Desmos, you can see you actually put the parentheses around the 1 plus R over N. And then when you do the exponent, because again, we need to tell Desmos that they are one quantity. So you can see the parentheses is also around the exponents. Were you not able to come up with these
No, I
numbers?
didn't get that. That's why I was confused.
Okay, so try it now with putting the parentheses around the 1 plus R over N. And then in the exponent, also make sure you have parentheses around the N times T. Anybody else have a question while Belicia is checking her answer? Anyone who did not come up with this at all? Okay, well, you can come and talk to me later if you don't wanna talk in front of your classmates. I know they're pretty scary, I'm with you. Trying to see if I can find one on compounded continuously. Am I just not reading this correctly? Let me know, Belicia, if that works out for you or not. So it should be, what was that, 27,172.37. This is just doing comparison, simple compound interest. Compounded monthly, compounded weekly, quarterly, annually. Quarterly, weekly. Compound interest annually, compound interest. There we go, number 17. So let's look at him. I guess it wouldn't matter, 17 or 19, but yeah, let's do 17. You deposit $2,500 into an account earning 4% APR compounded continuous, and kind of the similar questions. How much will you have in the account in 10 years? How much total interest will you have earned? And what percentage of the balance is the interest? So we're looking at 17 over here. So I'll let you write those numbers down if you need to before I copy and paste it over in our spreadsheet. So you're depositing $2,500 for an APR of 4% compounded continuously, and they want to know the balance after 10 years. All right, let's do another spreadsheet here. So we need to identify the PR. Since this is compounded continuously, will we have the N value? No, we will not. And remember, this guy is P times E raised to the power of R times T. And then for E, remember we use the EXP function. All right. What is our p-value, principal present value in this guy? Thank you, yes, and then let's format him to a dollar amount, the rate of interest. And again, we'll need to get rid of those extra zeros. And then, of course, they're asking us to do this over 10 years. So that's your p-value. All right, tell me, what does our account have after 10 years have passed? You have an answer, Megan? You kind of look like you're done. You have an answer? Okay. Well, you can try using this guy. He's ancient. He's trustworthy. I did drop him the other day, so. I actually dropped one of the calculators I brought from the math department the other day, and it like ink blotted over the window where you see the numbers. And I was like, how cheap are you? That one, I mean, I have dropped that guy, and I've had him since graduate school. Oh, knock on wood. I've dropped him many times. Let's just say that. He's been dropped many, many times. Thankfully, not a problem, but the one I took back the other day, just like. And then this like purple ink blot, and then I took it to my chair and I was like, I'm sorry, I did this. Not my students, it's my fault. He's like, oh, we'll buy you a
One of my
new one.
students did this. Which one? I don't
No,
know.
Samuel, he's the troublemaker. So no, the chair was okay. He's like, well, we'll just buy some more. Apparently that happens a lot.
They're cheap.
Yes, and I was disappointed because they were like TI calculators, so it's not like a, made in, but everything is made in China, but not like a
Yeah.
Dex, blah, 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 China, something, I mean. Alrighty, what is my balance after 10 years? Somebody give me something.
1491 and 82 cents. That's what I got.
But you can't go below 2,500.
Oh, I started with 1,000.
That's why you're so messed up. I got 3,000.
Or mine's messed
I
up.
was gonna say
Never ask Samuel for answers. 3,000?
I never think.
729, 856.
Hell, I claim to be bad at math.
You were giving me the answer in such confidence. I thought you had the right answer.
That's what it is to be an American, is to be confidently wrong.
Okay, good. I think Jessica, you were also saying you had an answer. Was yours different than what we have up here? Yeah, you want to tell me what you have? No? Okay, that's okay. Anybody else have a number for me before I do the calculation? Okay, so at least we have two people, so that gives me confidence. All right, so let's do the math here. So our principal is 2,500, and then remember you multiplied with the EXP function for the natural number E, and then again, no caret, just inside the parentheses, we'll do R times T, so basically 4% times 10 years, and look at that. I do not need you to autofill anything. So $3,729.56. Alrighty, very good. Look at that. So that was part A. So very nice. We got part A. How much interest will we have earned? So part B. What's our interest here, people? Do we have at least $1,000 in interest or no?
Yes.
I think so, 37 minus 25, right? Should give us 1,100 and some leftover change. So you're taking A minus P. Remember, that's always how you come up with the interest calculation. So $1,229.56. And then part C was what percentage of the balance. So what percentage of the balance, which is A, is going to be the interest? Does anybody have that number? what percentage of the balance is the interest? Anybody wanna guess? I'm not asking you.
I know the answer. I plugged in the right numbers this time.
Okay,
Should be 33%. Or 0.329676.
0.3296,796.
404,937.
Oh, sorry, there should be a decimal somewhere in there, people. There we go, 0 point. So about 32, 33%, yeah, like you said.
Yeah.
Alrighty, and then we'll leave the rounding to homework problem, so whatever the homework problem will tell you, you can round it based on. Look at that, I really did not have faith in you. But you did good, very nice. I guess we can go back to trusting Samuel every now.
I mean, as long as I get the right information
So-
here, then we're good.
Yeah, I mean, I'm still surprised you used $1,000,
But there's
but,
just a disconnect from there to there,
okay,
then to there.
okay. Raven, are you doing okay on Zoom? Did you have any questions on this guy here? Anybody in the classroom have questions on continuous compounding example here? Yeah, so we're gonna rock this homework, 100% for everyone? Just lie to me. Didn't I tell you guys the other day, just lie to me, make me happy? And just say, yes, we're gonna get 100%. Alrighty, guys,
Found out where I got the 1,000 from.
where?
Scroll up a little bit.
Number 18?
Yeah.
Okay. Well, then I will take that as an honest mistake and not something done on purpose. Let's see. I like number 20. So yeah, because they're doing a comparison here, let's take a look at this guy. And before Sam copies over some other problem, just gonna copy paste here, so takes the confusing variables out. Hello, why are you hiding half of my problem? Here's the second half. All right, so you are depositing $10,000 into an account that is earning 5.5% APR compounded continuously. And this is kind of what I was hoping, that we could show the difference even between continuous and regular compounding. And your friend is depositing $10,000 that is also earning a 5.5% APR, but this guy is compounded annually, right? So that means we're only calculating interest once a year. So they want to know, how much will you have in the account in 10 years? And this is for both accounts, even though they didn't specify that. And how much interest did you earn over that 10-year period? So we're talking about you and we're talking about your friend. So let's make two separate calculations. So they will both have a principal. They will both, of course, have an interest rate. They will have a compounding period. And of course, we're talking about time in years. Alrighty, so let's see. For us, it is $10,000, which is actually the same for the friend also. I'm just gonna do a copy paste here. So 10,000 for the friend. They are also both earning the same interest rate, so it is 5.5% for both friends. Make sure we get rid of those extra zeros, put a decimal in there. And I'm again gonna do a copy paste there. Now we are compounded continuously, right, for our account. So I'm actually just going to say continuous here. If I can spell it, continue. That looks right. And then the friend is compounded annually, so that actually tells us N would be 1. And then they're doing this over 10 years of time. So that should give us all the basic information. So again, you can use the formula or you can use the built-in function for the annual. And then of course, for the continuous, we have only one option to use. So that's going to be the A equals P times E, right, to the power of R times T, so we don't have any other option for continuous compounding, oh, be careful. And then for the annual compounding, you can use this little guy over here divided by N. Raised to the power of N times T, or you can use the built-in function, whatever you want. And then again, remember for E, we use EXP. So let's see, what will we come up with if we try to do continuous compounding? So, and I think this problem is great because they're keeping the dollar amount and the interest rate the same, right? So this is literally just comparing what happens if you do continuous compounding and what happens if you do annual compounding, which you can change that annual to other compounding periods, right? If you just wanted to see, like, I might be curious, like, how much does a daily compounding compare to continuous, right? But right now, we're just gonna solve the problem as it's given to us. So we are doing the principal multiplied by, again, we will use the EXP function for the natural number E, and that is being multiplied with R to the power of T. Right? So that guy is coming out to be, looks like $17,332.53. Did we get that? Are we still working through the calculation? Because I think I'm blocking the view there a second. And I think that's it for this fella here. Let's do the friends calculation. So that's going to be, again, principal times 1 plus R divided by N. And then raise that to the power of, again, I'm going to put that in parentheses. So N times T. Hello, what did I do? Why are mine? Oh, because I forgot to put multiplication there. E to the 9 asterisk times 1 plus R over N to the power of N times T. Okay, okay, so yeah, try using the asterisk next to the principal amount.
It's because the spreadsheets don't recognize the parentheses.
Yeah. The rate would be R divided by N. If you're using the FV formula, the number of periods would be N times T. Payment amount, again, always 0 for our purposes, and then our principal was $10,000. And then again, this guy can see. Oh, so the poor friend is not making as much as the continuous, which doesn't surprise us, right? Because it's only being compounded once a year. You can see it is not going to be as quickly as a continuous compounding. All right, any questions on this? All right, so I will save these spreadsheets again if you guys wanted to go and look at it for homework help or whatever. So let me know if you have any questions, guys, and if not, I will see you on Tuesday. So have a wonderful weekend, everyone. Be careful, stay safe, take some snacks. Raven, did you have any questions on? Hello, who is that?
This is my cat.